go over this. So, Brandon starts with $20 in his wallet and earns $10 each week. Brandon, what would it be? Linear. Does everyone get why it would be linear? Because linear is adding or subtracting over and over again. What is he adding over and over again? Good. He's adding $10, so that would be his slope. Cool. Tristan, you're doing the next one. Tristan puts $100 in his bank account, earns 3% interest. He's not in here, so if he wants to take this. Victor, you're going to take this. What type of function is this? Linear, exponential, or quadratic? Exponential. So remember, when there's a percent, it's usually exponential because you're multiplying by its decimal. Damon, you're doing this one. Damon throws a football to Tyreek that goes 15 feet in the air. What type of function is that? Yep, quadratic. Because when you're throwing a football, it looks like that. So we know it's a quadratic. Last one, Michael. Michael plays Angry Birds where he tries to get the bird, and so he's, you're projecting something. So Michael, what type of function would that be? If you're playing Angry Birds and you're projecting something in the air, what type of function would that be? Not exponential. What would it be, Tyreek? Quadratic. Because you're going like this, right? You're trying to the Angry Birds. Yeah. So quadratic, beautiful. Cool. So we're going to be reviewing word problems today. This is our last lesson before your test tomorrow. We'll have review first period, and then we'll have third period. We'll have our test. So get your notes out. These are pretty basic notes. So we're going to be going through what type of function is it? What is its equation? So a lot of us forgot how to write equations. And then solving it and sketching and what it looks like. So this says Allie loves to read. She reads at a rate of 25 pages per hour. In her book, she already read 40 pages. What type of function is that? Not quadratic. Linear. It's linear because you're adding, like if she's reading at a rate of 25 per hour, that means each hour she's adding 25 pages to what she's read. So we know since it's adding, we know it would be a linear equation. Or if it was subtracting, it's still a linear. Write an equation that models this. So first of all, which number would be my slope? 25, right? Because that's what you're adding over and over. So I know 25 would be your slope. I also know that word per. That indicates that it's going to be my slope. So like per, each, every indicates something's a slope. Then what would be your y-intercept? There's only one other number there. 40, right? Because she already, remember, y-intercept's like your beginning amount. She already read 40 pages. So I know that that 40 would be my y-intercept. The linear equation, and remember, we always have that in our formula sheet, is y equals what? Good. Mx plus b. And we know that our m is our slope. So what instead of m, what am I going to put? Good. 25 x. And what's your y-intercept? 40. Cool. So this all, again, it's all review, this whole unit. This is just kind of putting together all three types of functions. How many pages will she read after 2 hours? How much does she read per hour? 25, right? So I can figure out, okay, I'm going to plug it in for x to figure out, okay, if there's 2 hours, I'm going to plug in 2 for x. Or I can even think logically. Like I know when Damon used to do word problems, he would just write out, okay, I already have 40, then add 25 each time. How many times would we add 25 in this case? 2 hours, right, to get 50. So we have 25, another 25, and they already read 40. This right here is the same thing as this. It's whatever way you want to do it, but putting that in a calculator and doing this is exactly the same thing. What do you end up getting? Good. So either way, you end up getting 90 pages. what would it look like? What does a linear equation look like? Straight line, right? And since it's a positive slope, it would be going up. So you just draw a little line with it. If it was subtracting, it would be going down. Does that make sense? Is all got that? Cool. Let's go to the next one. A soccer ball starting from the ground is landing halfway down the field. So here we go. Here's our field because we want to sketch what it looks like. Here's Steven. There he is. Here's the soccer ball. What type of function is that? Quadratic, right? Because it's that parabola. So I know this function is going to be quadratic because it's a parabola. Then I already sketched what it looked like, but you're also, what is the y-intercept here? What's his starting point? Does it say anything about a starting point? So what is it? 0. So in quadratics, usually, unless like someone's standing on a roof, because it's height, usually it's going to always be 0, 0. Don't let it trick you. On the test, it is going to trick you with different numbers with that. But it's 0, 0 if you're just starting. It would be higher if like Steven was kicking a soccer ball off a roof, right? Then the y-intercept would be however high it is. Does that make sense? Basic? Cool. All right, $750 is invested at 14%, and don't worry about this. We're not going to learn that because we don't really have time because of how crammed we have to do your thing, but you won't see it on the milestone, so don't worry. So what type of function is this? Exponential, because we're multiplying. So exponential, what is the equation for exponential? Y equals what? So to the A. What's the next one? X is at the top, and what's the letters right here? B. Good. AB to the X. And so we haven't done exponential in a little while, so I want to make sure we remember it. A is your y-intercept. I know B was it in the last one, but A is in this one. So what is our initial amount? How much did they put into the bank? 750, right? That's what he started with. So my A would be 750. B, since I see a percent, remember if it's doubles or triples or half, I would just put that right in the parentheses. But now since there's a percent, remember that 1 plus 1 minus, I'm going to have to do that for my B. So we did 1. And then if you're investing something, are you getting money out of it or losing it? Then you're actually getting money out of it. If you invest something and then it fails, then you'd be losing it. But if you're investing in something and getting a percent, it would be plus. Then 14% as a decimal, remember you can just put it right into your calculator. You do 14, second, and the parenthesis sign. So if you do 14, second, and the parenthesis sign, it gets you 14% as a decimal. It might be the other. All right. What is it as a decimal? 0.15, right? We just divide it by 100. And then the X. Oh, thank you. So 0.14. Cool. So that's my equation. If you want to simplify it, so like some of them may be simplified, I just rewrite it. And what is $1 plus 14 cents? $1.14, right? So you could just put that right into your How much money would be in the account after 8 years? Where do you think I put that 8?
Oh.
Good, incorrect. So I'm going to rewrite this and put it right into my calculator, or you could put it into table and find when your X is 8. Either way, it's the same exact thing. Who can tell me how much he would make? 2,139 and like 44 cents. And that makes sense, right? If he's starting with that amount of money, he should be getting more money. My answer should be more than what it started with. Sketch what that would look like. So what does an exponential function look like? Is it a parabola, is it a line, or a curve? Curve, right? And since it's growing, it would look something like that, where it's like a little curve like that. Cool. So now the next one, you would do the same thing, but now it's losing value. So you know, like when you buy a car, no matter what, it's going to lose value. So like even though you bought it for $20,000, if you're like, hey, I don't want that car anymore, and you sell it, even if it's like a day later, it loses value exponentially. And so this new car is worth $20,000 and loses 30% each year. What type of function would that be? Exponential. Every time you see a percent, usually in Algebra 1 in your test, it's probably going to be exponential. Then write an equation. So what is your A value? What's your starting value? 20,000, because that's what they started with, right? That's how much the car was worth. And now, in my parentheses, is it going to be 1 plus or 1 minus? Minus. And what's 30% as a decimal? 0.30 or 0.3. The x. So when I write it all together, it would look something like this. What's 1 minus? We end up getting 0.7, which remember, if it's under 1, if it's under $1, I know it's decaying. If it's over $1, it's growing. So remember that for me. How much would it be worth in 4 years? What do you have to do? What do we do for the other two? What do we have to do? Look this forward. Yeah. Plug it in for x. So again, this isn't anything new. Remember that. This is just like putting what we've learned from those 3 units together. What do you end up getting? What's it again? That's a lot less money, isn't it? Do you guys see that? That car started, and this is how cars actually work. That car is worth $20,000, and 4 years later, when you trade it in, it's only going to be worth $4,000, $4,800. So be careful when you're buying a car that's good value, good gas mileage, everything like that, because you can see when you trade it back in, you're barely getting money for it. And what would this look like? Is it a curve, a parabola, or a line? Which one is it? No one knows? Curve, right? But now see how that curve looks like it's growing. This one's decaying, so it's going to look like that. Do you guys feel okay with this? Yes, no, maybe? Okay, so what you're going to do is you're going to finish the last, how many did I not go over? Like 2 or 3 examples. So it's a pretty short lesson. You're doing 2 or 3, the 2 or 3 left, I'm going to come around, stamp them. Then what you're doing is your ticket out the door, so it looks like this. So these are the examples, like this one says, Keandra's taking a test worth 100 points, but loses 10 points for each question wrong. And I want you to tell me what type of function, what's the equation, and what's the y-intercept. This one says, Stephen kicks the game-winning goal in a soccer game from 15 feet away from the goal. What type of function is it, and what's the y-intercept? Last one, Brixiana puts $1,000 in her bank account and spends 10% each week. Sound good? Cool. So you're going to be doing these problems. When you're done, if there's anything on that sheet that you don't like and you maybe, hey, I didn't do well on the quizzes from last period, I kind of want to try it again. I'm going to give you the rest of this period, I can't speak. The rest of this period to kind of get your grade together. If you're done everything, you can start your review sheet because your test is tomorrow. Sound good?